Welcome to this YSL tutorial. In this video we're going to teach you how to use table-valued functions in Microsoft SQL Server. We'll begin this session with a very quick recap of what user-defined functions are, before we move on to show you how to create the most simple type of table-valued function, which is referred to as an inline table-valued function. We'll show you how you can use those in queries that you'll subsequently write, and how you can also modify those functions should you need to. Once we've dealt with the basic table-valued functions, we'll move on to the horribly named multi-statement table-valued functions. We'll show you how you can define an MSTVF, which is no less horrible acronym, how you can then use table variables within its definition to hold the set of results that will finally be returned, and then how you can use these MSTVFs in your future select statements. So let's get started. In a previous video, we've shown you how you can create user-defined functions, which you can then employ in your select statements to calculate new values. So in this example, we're using a function called fnLongDate. It accepts a single parameter, which must be of date time, and it returns a nice long string of text, which is that date formatted in a neat way. So when we execute the query, we'll see its output. Now this type of function is referred to as a scalar valued function, and this type of function always returns just a single data point each time it's called. But in this video, we're going to teach you how you can use a type of function which returns an entire table as its output, the so-called table valued functions. To demonstrate the basics of table valued functions, we're going to create a function which returns a list of the films made in a specified year. And the basic logic of that could be explained in a simple select statement like this one. So we're selecting a number of columns from a certain table, and in the where clause we have a single criterion where we're looking for all the films where the year of the film's release date is equal to the year 2000. When we've created our user-defined function, however, we're going to be able to encapsulate this logic in a much neater way. So here's how it will look when we've written the function itself. We're selecting the same columns from the table returned by this function. So it's exactly the same conceptually, the set of results will be the same, it's just that we've encapsulated all of the logic in this neat, easy to reuse package. To begin creating our table valued function, we need a new query window, and I've already added in the first two basic statements which tells the code to use the movies database, and then go, which begins a new batch. And that's important because the next statement must be the first one in a batch, and that's to create a function. Exactly the same as though you were creating a scalar valued function, if you remember having watched that video previously. We then need to think of a sensible name for the function. I'm going to call mine films in year, and following that we can define which input parameters our function will have. Now if you think back to how I demonstrated that function being used when it was created, the function requires a single input which must be some kind of a number. So that helps us to work out what we want to do here. In the definition of our function, in a set of parentheses, we're going to define a single parameter. I'm going to call it @filmYear, and I'm going to declare the data type as int. Now that we've said what kind of data goes into the function, we can say what kind of data comes back out. And hopefully, obviously, the return type for a table valued function must be a table. So the statement is returns table. Now with a simple table valued function like the one we're creating here, this is referred to as an inline function, or an inline table valued function if you prefer. We don't need to specify anything else whatsoever. We don't need to define what columns the table will have and what data types they will have. It's all implicit in the select statement we use to return a value. So returns table is all we need for this particular kind of function. Having said that, we do need to define what the select statement itself is. So we must do that with a couple of other keywords. So returns table as, and then we're immediately going to return an answer. And the answer will be the select statement we'll use to populate the results of the function. Now at this point I'm actually going to cheat, because I still have my simple query open up here, which I'm going to copy most of the code from, everything but the explicit value that I'm using to demonstrate this basic query. So I copy that part of code, pop back to my function definition and paste it in. I better do a quick bit of indenting, otherwise I won't sleep tonight if that's not all neatly aligned. And then all I need to do is replace the constant value 2000, as I had earlier on, with a reference to the parameter that will be passed in when the function is called. So that's going to be @filmYear. And there we go. That's the definition of our function. What we need to do next is execute the code to create it. So that's all I'm going to do. If I execute the code, what we're looking for is commands completed successfully. Once you've successfully created a table valued function, you can find it as part of the database in the same way as a scalar valued function. So to do that, you'll need to be in the Object Explorer, and you'll need to have expanded the database you've created the function in. Then you need to look for the programmability folder, within there the functions folder, and finally within there the table valued functions folder. If I expand this, I should find that my function is sitting there. If to begin with you don't find the function sitting in the folder where you expect it to be, try right-clicking on the folder and choosing to refresh it, and that will update the folder content so you'll be able to see it. You can then expand the function itself and look at what parameters you've defined for it, including what data type they've been given, but that's just a reassurance that the function you created is sitting there. Now that you've established that the function is where it should be, the last test really is to try to use it in a query. So fortunately we already have one open here, in fact, which tests our films in year function, and we're passing in the year 2000, so if I execute this code I should find that I get a list of all of the films released in the year 2000. If I have a quick tweak here, let's update the year to 2001, execute the code again, and the results are updated automatically. A couple of points worth mentioning: you must include the schema that the function belongs to. So in this case it's dbo.filmsinyear, but the schema name is important when you're using user-defined functions. It's also possible that you don't actually have to type out this this phrase. You can actually drag the function name in directly from your Object Explorer, in which case you can then open the parentheses and add the parameter as necessary, and so on. Once you've created the function and found that it works, what happens if you decide you want to modify it? So for example, maybe I'd like to be able to use my function to find films released between two different years. So what I can do to modify a function, well, one of two things in fact. First of all, I could use the script that I used to create the function in the first place. I could simply then change the word create to the word alter, and then modify the code which returns a different set of results. What I could also do, if I don't have that code available, so let's close it down without saving the changes, is I can find the function listed in my database, right-click on its name, and choose to modify it. And that will open up a script which is essentially exactly the same code as I wrote to begin with. There are a few extra system-generated lines of code, which in this case aren't necessary, so I'm going to delete those. And after that, essentially everything is exactly as you wrote it. So what I'm going to do this time, I'm going to create an extra parameter. So I'm going to rename the first one as start year, and then add a second parameter, which will be at end year, and that will also be an int data type. Then I'm going to modify the where clause. So I'm going to look for where the year of the film's release date is between at start year and at end year. All I need to do now is execute the code to modify the function itself. Don't forget to do this. Simply writing the code out doesn't physically change the way your function works, so you must execute the code to actually alter the function. I can't tell you how many times I've embarrassingly forgotten to do that. So let's go away and give this another try then. So we still have our code open which uses our films in year function, but it now has an extra parameter which I should need to provide. So I'm going to add in the year 2000 followed by a comma, the year 2002. The squiggly red underline is simply because the IntelliSense hasn't yet refreshed itself. It doesn't yet recognise that there are two arguments now, two parameters for this function. So I can refresh that in one of two ways. I can head to the Edit menu and choose IntelliSense, and then choose the Refresh Local Cache option, or just press Ctrl Shift and R on the keyboard. I'll click the link in the menu as it's there, and eventually the squiggly red underline will disappear. If I finally execute my code, I should now find I get a list of films released between the years 2000 and 2002, or whichever 2 years I decide to pass in each time I call the function. So we've seen how to use basic inline table-valued functions. What we'd like to move on to next is something a bit more complicated, the so-called multi-statement table-valued functions. It's a horrible name, but a really useful feature. So the idea is that we can create a function which doesn't just return the results of a single select statement. We can perform multiple select statements, build up an entire table of results from various sources, and then return the entire thing as the final step. And the example we're going to create for our multi-statement table-valued function is one which allows us to find all of the people who were born in a specified year. So here's our function people in year. We're passing in the year 1940, and it's going to return all of the actors and all of the directors who were born in that year. So when we execute the code, that's what we get. And of course we can change the year to any year we like and get a completely different set of results. The starting point for defining a multi-statement table-valued function is very similar to defining an inline table-valued function. So we have the basic use movies and go statement, which means that create function is the first statement in the next batch. We've created a unique name for our function, people in year. We've defined a single parameter contained in a set of parentheses called @birthYear. The data type is int, and that brings us to the returns statement. Now previously, for an inline table-valued function, we can simply say returns table. But that's not quite good enough for a multi-statement table-valued function. What we need to do is declare a table variable and say that our function is going to return the value of a table variable called, in this case, @t. As the end user will never see the name of this variable, it's fairly unimportant what it's called, so we get away with something very short and succinct. We've made a video on how table variables work previously, so it might be worth a quick watch of that video to get a feel for how table variables work. But all we're going to do at this point is define which columns and data types this table variable will contain. So we're going to have three. We're going to have a person name, which will be varchar max, because we're not quite sure how big the field will be. We'll have a field called person DOB, short for date of birth, and that's going to hold date time data. And finally, we'll have a field called person job, which will be varchar, and this will contain either the word actor or the word director. So the longest word in that pair is 8 characters long. So that's the biggest difference so far with a multi-statement table-valued function. You have to return not just a table generically, but a specifically defined table variable. The next step is to write the statements which will build the set of results before they're finally returned. So we can do that with an as keyword, and because we've got several statements involved here, we should wrap them up in a begin and end block. At that point we can then begin inserting records into our table variable. So to do that we're going to say insert into, beg your pardon, @t, and the values I want to select into the statement, into the variable the first time, are going to come from the director table. So I'm going to say select from TBL director, and the three values that I want to insert: the director name first, followed by the director date of birth, followed by simply the word director, so the literal text director. I want to add a where clause to make sure that the records are only inserted where the director's date of birth, the year of the director's date of birth is equal to the value passed in via the @birthYear parameter. So @birthYear, and that's the first set of records that will be inserted into the table variable. Now, fortunately, with such a simple example, I can get away with a quick bit of copy and paste here, because the next thing I'd like to do is insert a set of records from the actor table. So with a quick bit of find and replace, I can find the word director and replace with the word actor. Close all that down, and that's all of my information inserted into the table. All I need to do now is tell my function to return a value. The last statement in any function's definition should be to return a value. Now, because with a multi-statement table-valued function, you define what the return thing is, what the function returns, all you need to say at the very bottom is literally the word return. So all we need to do now is execute the code to actually create the function, which I'm going to do now, and hopefully we'll see commands completed successfully. And then all we need to do is test that our function works. So we create a new query window. I'm going to say use movies, and then I'm going to select everything from dbo.people in year, and I'm going to pass in a single parameter, let's say 1945, and execute the code. And hopefully, as expected, we'll get a set of results based on the year that we've passed in. Just for the sake of completeness, it's worthwhile mentioning that multi-statement table-valued functions can be found in the same place as the inline versions. So we find the movies database, programmability, functions, and table-valued functions. Again, we might find that we need to refresh the folder in order to make the functions appear, but then you'll see them pop up. And again, you can modify these or delete them in the same way as for standard inline table-valued functions. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.